Today we are going to discuss the notion of a rate of change. This is one of the very fundamental ideas in calculus. A natural way to approach this idea is through the idea of speed. Speed is how far an object moves in a certain period of time. The value of an object's speed is found by dividing distance covered by time elapsed, for example, miles per hour. We know that if you throw a monkey off of a cliff, it will fall toward the ground. Galileo discovered around year 1600 that the object falls with a speed proportional to the square of the time it has been falling. Y equals 16t squared provides a good approximation. Y is the distance the object has fallen. T is the time the object has taken to fall that far. We write the change in y divided by the change in t as our speed. Distance divided by time. We want to determine the speed at time equals 1 second. Let's take our time interval to be 1 second. Average speed for the object is how far it has fallen. Let's do the calculation for 1 second of time interval after the 1 second mark. 16 times 2 seconds squared minus 16 times 1 second squared divided by 2 seconds minus 1 second equals 48 feet per second. Here's the big lesson. What happens when we shrink this time interval down? Look at the graph of y equals 16t squared. Here's the point y at 1 second. Here's the point y at 2 seconds. Our line is the velocity we calculated, 48 feet per second. If our second point of calculation is moved closer and closer to the 1 second mark, what happens to this line? Decreasing the time interval from 1 second to 0.1 seconds to 0.01 seconds, here are the values calculated for the speed during the time interval. What is happening to the value? It is approaching a limiting value. Join me next time when we discuss average rate of change.